Hey guys, glad you could join me again. Last time we started building a handler for signing up a user with an email address and password. We learned how to validate and bind incoming JSON on a request body to a struct, and then how to call the user service for signing up a user. Today we want to complete this handler by having it reach out to a token service, which creates something called an access token as well as a refresh token. These tokens are what we'll use to authorize users to the eventual memorization app we plan to build. In a real-world scenario, these tokens could be used to access various applications or microservices in our company or organization. These tokens are generated based on authenticated user data. As you can see here, we've already created and signed up this user by calling the signup method with data received from a request body. So what we'll do today is add more code below for creating tokens from this user, you. But before we use this user to create tokens, I want to clarify that we'll definitely go into our auth flow later. But for now, we're going to just focus on this handler code. And for those of you with some experience in this area, I'll include a rant and links on the vigorous debate of token and session ID storage with links for you to read on your own time. Suffice it to say, neither of the common methods is safe if you're vulnerable to cross-site scripting attacks. Even storing a token or session ID inside of an HTTP-only cookie with same site equals strict. But I digress, so let's move on to adding a tokens model. Inside of this model folder, let's create a model for a pair of tokens. So let's do this by right-clicking model, new file, and let's call this token_pair.go. As a reminder of how models look, let's look at our user. The models contain data that we can share, or the structure of data that we can pass between various layers of our application. If you look here at the user, you can see it'll have a user ID of a type called UUID, and then email, password, name, image URL, and website URL as strings. And then it also contains these struct tags and backticks, which define how these will look in the database. So in other words, an email will be stored with lowercase email inside of an SQL database. And then JSON returned to a user or received from a user will be stored according to these JSON struct tags. With that review of how these models look, let's go back to token pair and create it. So I've now added the token pair struct, and it's very simple. It will store an ID token, which for our application will also be the access token for those of you familiar with tokens, or authorization tokens to be specific, and a refresh token. And these are both just going to be sent to the users as strings on the following JSON keys defined here. We're also going to need a method for creating these tokens. So let's open up our interfaces.go so that we can create a token service and define a method for creating these tokens. As you can see, we've added this new token service with a single method so far. So we expect our token service to have a new pair from user method, which receives a context, which we'll receive from the handler layer in this case, a pointer to a user, which is our models.user, and a previous token ID. Now, for what we're doing today, we're not going to use this previous token ID. This will be used later when we create a refresh token to invalidate previous refresh tokens in a cache. And just as a heads up, that will be stored in a Redis database. With this interface created, we need to be able to access token service methods from inside of our handler layer. And how do we do that? Inside of the handler layer, we need to go up to the top here, and we need to instantiate it or add the property inside of the handler struct. And when I say instantiate, we'll do that inside of this factory function here. So let's go ahead and do that. All right, I've added this token service to the handler, to the config, and then from this config, which is passed to the new handler function factory. We then extract it to create the actual instance of the handler here. Hopefully that makes sense. I was scrambling my words there. With this set up, we're now ready to access the new pair from user method of the token service inside of our handlers. And in this case, we want to access it inside of the signup handler here. So let's go back. Recall that last time we previously bound the incoming data to this request object, or not object, but struct. I guess Go isn't object oriented. I always interchange words, so you'll just have to accept that or lambast me in the comments. But here's the structure of that signup request. We extract the email and password and create the user by calling the user service. And so we're going to assume we've gotten past this error section and we can now create tokens from this user. So here's the code for calling the token service.newPair from user method here. And it returns either the tokens, which remember is that struct we created earlier in the model layer. If there's an error, we're going to log this error for internal use of our application from the mythical logger that we're not actually going to implement, but you could extend this or use another logger of your choice. And then we're going to return this error as JSON. And by error, I mean the one returned from the user service. And then we return and we do nothing else. If the tokens are successfully created, we'll return them on a tokens key as JSON. So hopefully that wasn't too bad. As we've already done a few times, now we need to create a mock implementation of the token service and implement the new pair from user method so that we can test our handler. So inside of our model layer under mocks, let's go ahead and create a file for the token service. All right, so we've created the token service file. And let's make sure we include it in package mocks. The first thing we need to do here is add the struct definition of the mock, which will contain the mock field inside of it from the testify package. And I'll save that and import it automatically. Now, if you need a review of how these mocks work and the code we're going to include here, please see previous tutorials to help out my YouTube metrics and just watch the whole thing, by golly. Or go ahead and look at the testify documentation. That's probably faster, but of course I'm selfish. Alright, so here's the code for the mock implementation, which just basically defines the return types that we can have when calling this method. So let's go ahead and start scaffolding out the tests. So I'm back inside of signup test go now, which is right next to signup in the handler folder. And we left off testing if an error is called from the user service. This time, we want to create a couple of different tests, assuming we've successfully created a user, and we'll do that down here at the bottom. So what are the two test cases we need here? Well, first we need to test if tokens are successfully created, and then next, if tokens are not created successfully, we need to test for the proper response. When they're created successfully, we want to have an HTTP status created of 201, and if there's a failure, we want to relay or pass that error on as JSON as a response to the user. So I've added the first of those two test cases here. In it, we'll create a user with a valid email and password, and then we'll create a mock token response based on this recently defined token pair in the model layer. Now notice we're not returning a real JSON web token, which we'll be using later. We're just using some dummy strings, and that's because we do not want to test that functionality in this unit. It may be wise to do some integration testing later on, but to keep things simple, if not the best practice, we're going to do it this way. We then instantiate a mock user service using the user service mock as in the previous tutorial, but this time we also create a mock token service, which we just defined. We set our expectations for responses on calling the methods in these services. So when we call the signup, we want to return a user. Actually, the signup method of the user service only returns an error, And if there is no error, the user will be stored in the reference to this user here. And notice that this U is a reference to a user with this ampersand here. For the mock token service, when we call new pair from user, we want to return the mock token response and nil for the second return value of this method. I keep calling return values response parameters. I don't know where that came from. Probably the intellectuals out there are getting really mad at me. But I don't want to be an anti-intellectual YouTube channel. All right, so then we set up our router with Jin as before and our handler, but take note that this time we're injecting this mock token user service. Now, we didn't do that before. We don't have to go back and add that to previous tests because this dependency was not necessary in those tests. We create a request body by serializing our JSON or by serializing a map with the email key and the valid email and from above, and then a password using the user.password defined above. We then send this request using the post method to the signup handler or the signup endpoint. And we make sure to set the content type to application JSON as before. And then we define an expected response body here. So maybe I should call this expected response body using the mock token response above on the tokens key. And that's because in signup, we expect the successful response on the tokens key. We then create our assertions. We want to make sure that our HTTP response has a status created code, which is a 201. And then we want to make sure the response body, this defined here, is equal to the actual response from the HTTP handler. And then these two lines just assert that the methods from our mock services were called. All right, let's now add a test method for the case when calling the mock token service returns an error. So here's the code. We do the same thing with the user here because we expect to successfully sign up a user with the user service. But this time, instead of creating a mock token response, we create a mock error response using our custom app errors internal error, which returns a 500 internal server error. We then create our mock services again, but when we call new pair from user this time, note that we return nil for the token pair, but the mock error response for the second return value. We set up our handler the same as before. We send the request body exactly like we did last time. The main difference is then we set the expected response body to have an error key with the mock error response. And again, this error key is because that's how we defined it in our actual handler. Finally, we're going to assert that our error response of the actual HTTP status code is that from the custom mock error response. And the reason we can just call status here is because that method exists on our app errors package, and we're using a custom app errors here. And then we also assert the response body here, the response body from the HTTP response is the same as that defined above. And in this case, we also expect both our methods to have been called. So let's go ahead and test this here by running go test, and we'll use verbose, and I wrote that wrong, and we'll do the handler package. Bazzow, and they pass. And of course, you're going to want to test that these fail. So for example, let's go to this test, and instead of testing for status created, maybe we'll say status length required, and we'll run that test. And of course, it's going to fail. And if we go up to the details, I guess status length required is a 411, but we actually got a 201. And I encourage you to make these tests fail, maybe create some more tests and tell me what you think is necessary to test, and that would be great. Let's turn this back to http.statusCreated, and that'll be all for today. So thanks again for taking the time to follow along. I hope you've learned something useful. There may be a little delay until I release the next video because I'm simultaneously working on a view store library that uses TypeScript and implements or creates an API similar to ZooStand, which is a state management solution most often used with React, though it has a vanilla JavaScript library as well. I'll publish this article on my dev blog, so keep an eye open if you're interested in that. Until next time, ciao.